Sometimes we cannot resist indulging in something sweet. We put a dash of honey to go with our breakfast to sweeten things up, and in the summer our trips to the ice cream shop become more frequent. Sometimes when we bring our lunch, we add a piece of fruit to go with it so we can have it for a snack. These types of foods contain carbohydrates. Carbohydrates are biological molecules that contain carbon, hydrogen, and oxygen atoms. Carbohydrates are very important because they provide energy and fuel for our bodies so that our brains can function properly, and so that our muscles can work. Carbohydrates are our preferred source of energy. They can range from complex carbohydrates to simple carbohydrates. The simplest form of carbohydrates are monosaccharides. Monosaccharides are the simplest units of carbohydrates and the simplest form of sugar. They are the building blocks of more complex carbohydrates such as disaccharides and polysaccharides. Physically, they are usually colorless, can dissolve in water, and have the appearance of crystal-like substance. Molasses has a high content of the monosaccharide glucose. Cherries contain the monosaccharide fructose, and yogurt contains the monosaccharide galactose. Now that we know what monosaccharides are, let's take a look at how they're structured. Number of carbon atoms. We mentioned earlier that carbohydrates are composed of carbon, hydrogen, and oxygen atoms. Since monosaccharides are the simplest units of carbohydrates, then they are also made up of carbon, hydrogen, and oxygen atoms. Carbohydrates have this general formula. The possible values for n are positive integers equal or greater than 3. If, for instance, n equals 3, that means there are 3 carbon atoms, and these monosaccharides are called trioses. If n equals 4, there are 4 carbon atoms, so these monosaccharides are called tetroses. The following table shows the classification of monosaccharides based on the number of their carbon atoms, their general structure, and examples for each. You may notice that for arabinose and glucose, their structures open up from a polygon-like structure to a chain. This is because biochemists usually use 2 types of drawings called Fischer projections and Haworth projections to draw sugar molecules. The Haworth projections are sugar molecules depicted in their cyclic forms, and Fischer projections are open chain forms, as shown in the following image. The carbon atoms are numbered in the Haworth and Fischer projections so that each edge in the Haworth projection is 1 carbon atom. Carbon 1 in the Haworth projection is also carbon 1 in the Fischer projection, and so forth. Functional groups. Monosaccharides are classified as well based on their functional groups. A functional group is categorized by atoms or bonds that are responsible for the chemical reactivity within a molecule. If a monosaccharide contains a ketone group in an inner atom, then the monosaccharide is classified as a ketose. A ketone group